fault tolerance. This is a standard, and this is a Java standard for building microservices. Let me start with a brief introduction about the microprofile, and then we'll cover about what is microprofile fault tolerance. So microprofile is a Eclipse Foundation standard, and this is a Java framework for building microservices. As we know, microservices divide application into smaller components, and because of this distributed nature of the application, there are various challenges for handling the failures and ensuring system reliability. So in this section, we will be covering what are the mechanism which is available in microprofile so that we can build resilient and reliable microservices. This will help us ensure continuity and stability even in case of unexpected failures in our application. So let's talk about what is fault tolerance, and I will also be showing in my screen the code. I'll be having a working code. So let me start a code space. And then we will be looking into the code and how we'll be building it. So let me start my code space. So I already have various code spaces running in my repository. So you can go to my code spaces, and I see there is a code space which is I created based on Java. So I'll be starting this code space. So here on the right side, we have an option of running this code space. So I'm running this code space. It's setting up. It will take few minutes. So I'll introduce my example application, which is MicroProfile e-commerce application. And in this, this is a microservices based application. So you will see that this is MicroProfile e-commerce store. The project is called MP e-commerce stores. I have various microservices. So within source Java, I have a service, which is entity service. I have a product entity, which is a simple Pojo class representing a product, and within this product entities, we have various services as well. I will share them all, and I have used a Liberty server here as a runtime, and then this is my product entity. There are resources, product REST application. So this is my simple project. So to explain this project, I will start with pom.xml. In pom.xml, we have here as you can see, various dependencies. So I'm using microprofile. So here I will have the required dependency. So first dependency is the Fallback dependency. Then I have Jakarta EE. Earlier it was known as Java EE. So I have used the Jakarta EE 10 version. Then I have a dependency for MicroProfile 6.1. I'll be covering in few weeks about MicroProfile 7.0 as well. But right now we'll be looking into MicroProfile 6. And then I have JUnit, and there is a runtime to run tests. And there is the runtime, which is Open Liberty. So this is all about my microservices, which is, if you see here, this is REST application, and then there is the resource. There is some data which I have created. I've created two products. So this is a microservice. Let me explain another project. So this is a very simple project. As you can see, there is a Java file, and this is an entity. Actually, you have this as an entity, and then you have a resource where resource is the data, and then we have a REST application, which will be having this path, and a resource is having a path which is products. And when you run this application, it will basically return you the list of products. Currently we have these two products in the form of a JSON. I have explained this in previous videos. I'll be sharing my earlier video in the comments for you to look into it. So let me put two more video links for you. After this session, you can watch and go through these videos. This will give you a good understanding, so that you will not be puzzled about what is MicroProfile, how to run, and you will be able to do it later by yourself. So just give me a minute. I'm getting the two links and I'll be posting it in the comments. I'll also be creating a playlist, and in that playlist I'll be sharing the MicroProfile related videos all together in one place. So this is the video about we will be building microservices, starting with so this is I've taken code space blank. I will one of my earlier video. Go to the extensions, which explains how to set up this code space and how to get started with the project. Java. This we will be building microservices, starting with this is I've taken code space blank. I will one of my earlier video. Go to the extensions, which so there is one more video where I have explained about building more microservices based on MicroProfile. This is available here. Just give me another minute. I'll be posting that as well. That is a long 2-hour video. So this one which I've shared is a smaller one. It is a 20-minute video where you will get the introduction about microservices and how to set up the code spaces, etc. The other one is about to be getting shared. I'm just sharing in a minute. So if you want to use the JDK 21 or JDK 17, I have another video which is at this particular link. This is about installing JDK 17 locally on your system, and the previous video was about REST APIs, building REST APIs in code spaces. So these are the comments. Please check these comments and in the video links in the comments. I'll put also these links in the description for your easy reference. So I use only the online tools, mostly the Replit, or I use CodeSpace. I think it will take me 1 more minute, just 1 more minute for getting you the video URLs. Okay. This is Yes, so now I have got three links all together. I'll post it in the comments in the chat. So I posted about installing JDK 17. I also posted about developing microservices using Jakarta E and MicroProfile. And then I have this particular video, which is 2.5 hour video about how to set up the entire e-commerce application. And this is step-by-step tutorial for building your microprofile based e-commerce application. Equal to null, so here delete. I'll also put the title so that it is easier for you to look into it. Here I have covered a lot of standards, microprofile standards. So which include, when you build a microprofile based microservices, you get a lot of mechanisms for ensuring your microservices production ready. So there are RESTful APIs which comes from Jakarta E10 core profile standard. Then you have to do the documentation also. You can use Swagger or Open API. MicroProfile defines standard for documentation as well, which is MicroProfile Open API standard. That also is covered in the video. And then for ensuring the configurability, customization of microservices, we have MicroProfile config standard. This is also described in this particular video. And then finally MicroProfile health, which is for implementing health check, that is also described. So this is the video where you will be able to learn about the previous standards. Now today we will be learning about fault tolerance, and fault tolerance means your system should be able to continue working even in case of unexpected failures. A fault tolerant system is a system which is able to detect, isolate, and recover from errors automatically without human intervention. So here MicroProfile provides various strategies. First is the timeout. Any service which you create, there should be a timeout. How to implement a timeout, that also I will demonstrate. But right now I will be giving you some examples, and let's first cover the concepts. So these are the strategies for building fault tolerant microservices. First mechanism, which is most important and fundamental, is the timeout. Timeout limit your operation. It provides a time box, and it prevents indefinite waiting, and it also frees up resources if a service is taking too long. For example, if you are building a payment service and the payment processing is taking a lot of time, then the timeout mechanism will come to your rescue. It can basically stop the service, and it prevents blocking other processes. Next important mechanism for fault tolerance is retry. Retry is if there is a temporary network glitch or some transient error, you can have a retry policy, and there could be a delay between multiple retries, which is also very important. So MicroProfile provides API in the form of annotations, which you can use with any of the service to configure retries. for the application. This also will cover. Another important pattern or mechanism is bulkhead. Bulkhead isolates failure in one part of system. Here you set some limit to the number of requests. So this is another mechanism for ensuring fault tolerance. I will cover this, then it will be more clear. Then there is a circuit breaker. Circuit breaker pattern prevents an application from repeatedly making unsuccessful requests, and circuit breaker can open if there are some large number of calls which are failing, and then after some delay it can also allow some limited number of requests. This state is called half open state, and if request succeeds, the circuit breaker can be deactivated and all the requests will be allowed to go through. So this is one mechanism in which you prevent repeatedly making unsuccessful requests to another service. So we'll cover this in detail also. Then we have fallback mechanism. Fallback mechanism is if some operation fails, then you should have a fallback system. For example, if I have a payment gateway, if it fails, there could be a fallback which could notify user of failure, but they should be sharing the order, saving the order for future processing. Or a better example would be if I have a product catalog, if the service is failing, then instead of getting the real-time data price update, I might get the cached data. So this is fallback mechanism, which we should also implement to ensure reliability of our application. Then there is asynchronous execution. This is also another way where you have various operations running on separate thread. For example, you may run some analytics service in a different thread. So this way you can process a request without causing waiting, and it improves the responsiveness. So these are various strategies. These can be combined together to form your microservices based on your requirement for your application. You can combine them or you can use them individually as well. So let me again go to GitHub and a different project with more microservices where I will be explaining you. Just hold on for a minute. So this was my previous account, and here I will show you various microservices. So this is the product resource which I already talked about, but then there is a code space also where I have more services. Yeah. So here you can see my code where I have more services here. So here is my application. This is the e-commerce application. Its endpoint is API. Let me make the screen little bigger for you to easily understand. So this is my package where my project is there. Then I have used the Jakarta EE standard for creating an application. I have a service which is product REST application. I have a resource which is product resource. As I mentioned, there are CRUD operations defined on the product service. Then there is a repository. In the repository, I have created 2 products. So this is a repository. Repository provides access to the database operations. And this is my product Pojo object. I've created a logging interceptor as well. For creating logs. So again, in this particular GitHub account, I will have various code spaces. So I will go to the code spaces because that's most relevant for this particular video or particular session. And here is my code space. Okay, this is my Swagger hub also, where I have described the MicroProfile e-commerce application. So you can see here the details about all the APIs. Yeah, so here is my full-fledged application where I have health, I have all the product related, my e-commerce microservice related packages. So here is, as you see, I have this MicroProfile tutorial. So this is my top level directory. It's store. Store has an inventory service, payment service. So I have various products, various here sub projects. One is the catalog microservice, second is the inventory microservice, third is the payment microservice. So we'll be using all 3 of them, and we will be describing various fault tolerance API with respect to this MicroProfile e-commerce application. So just to start, we'll start with how to include the fault tolerance API in MicroProfile. I'll make this text a little bigger for you to easily understand it. Now in the project, most important part is, in any of our project, pom.xml. So in this particular pom.xml, we have all the dependencies. So we use Open Liberty, and then we have here various standards. So for example, MicroProfile matrices, this is for monitoring. Lombok, Jakarta E, and then the entire MicroProfile. So yeah, if we want to add the entire dependency, then everything within MicroProfile you will get. But if you just want to use MicroProfile fault tolerance, we can just use here this particular dependency. So this is how you will include MicroProfile fault tolerance API. Right? So Yeah, it automatically detects that there is some change in the dependencies and we have to rebuild it. So this is what you can verify all this from the MicroProfile Fault Tolerant standard in Eclipse. So I will share you what's the place for uh, MicroProfile Fault Tolerance is standard or documentation. So here let me also put this link also in our chat in Eclipse. So I will. So here you will see it will also describe about the dependencies which will be required for building your application. So log interceptor I've already covered. With help of your annotation mylog, you will be able to log. There could be priority also, you can set it. And there is a asynchronous also tag for asynchronous logging. And these are the various patterns. We'll also look into the GitHub project. In the GitHub, when I go to MicroProfile project, and I will show you in a minute. So this is the MicroProfile Fault Tolerant project within Eclipse Foundation. This is the repository where this standard is built. So to include the dependency, you see this is how so the group name is fault-tolerance. So let me fix this part as well. So now we have added the dependency for MicroProfile Fault Tolerance. So let's start with our first annotation, which is about making our service to have a timeout. Setting timeout is one of the most fundamental aspect of fault tolerance. So let's use it. So I go to my, let's say, any service where we want the timeout. It could be our service, let's say the products catalog service. In this we have various operations. Get products. Get products could be one service where we may want to have a timeout. Now how do I add the timeout? So timeouts are essentially a mechanism or a strategy to prevent long running operations. So if we are getting list of products for our e-commerce application, and if for some reason our service is very slow, unresponsive, then overall application may get very slow and it may not give fast response. So what we do is we will use a timeout annotation and we'll make this service timeout and display some error, or we can also have some fallback mechanism. So let's demonstrate both fallback mechanism as well as timeout. So to have this service timeout after say 2 seconds, we will just use annotation something like this. So you see here, this is very easy way to make any particular service time out. Again, I'll modify the project pom.xml. Here we should have fault tolerance, also dependency included in it. So we'll take the same from payment service and put this in the catalog service as well. So these are the dependencies. The dependencies include Project Lombok, Jakarta E, JUnit. This is the MicroProfile, and I'll also add fault tolerance. Yeah, we have to import also the fault tolerance timeout. So once this is done, this service will time out after 2 seconds or 2000 milliseconds. If you have a fallback method, you can also create a fallback method. Let me create a fallback method. For example, let's do this for payment service as well. So I'm going to the payment service. So here I can add a timeout. here again, let's say if we want to create for 2000, we'll create here. So again, the quick fix will be to add the package, import the package timeout. So this timeout retry is implemented. So let's also talk about the fallback. So if I have to create a fallback method, so here is process payment. Let's create another method which is a method to fallback in case this fails. So we have fallback process payment. This is just returning OK status or status failed or something, yeah. So in this fallback service, we are returning payment services currently unavailable. So what we have to do is we have to use an annotation fallback. Let me add here fallback method and fallback process payment. So this is as simple as just adding these annotations. What we have to ensure that this import packages are added and also dependencies. These all comes with MicroProfile. So see, this is so easy for your service to have a timeout, have a retry, have a fallback. So let me also explain about the retry. So you can check whether the fallback is happening or not by introducing a delay. So for example, if you want to test this, you can add a delay in your service. So here I'm putting some exceptions, but there could be some delay also which we can introduce to test whether timeout is happening or not. So this way we can introduce delay. So say for example 2500 millisecond. This will ensure the timeout will happen, and then fallback is also there in case there is some error. Then there could be a fallback or so this way with timeout you improve the resource efficiency because user resources are not blocked. You improve the user experience because user sees the error. It is not waiting for long time. But yes, you have to ensure that the timeout should be practical. So this is only for example purpose. 22 seconds may not be realistic. It may be too short. So based on how much processing is required for the particular service, you should have careful consideration and set the timeouts accordingly. So now let's talk about retries. Retries, you see here, there is a limit to the retry, which is also very important. So if there is failures, so what we can do is we can have timeout first. We may have retries as well. So we may have retries. For each of the retry, we may have a timeout. And if there is all the retries are failing, then we may have a fallback. So here between the two retries we have a delay which is 2 seconds. There's a jitter also added. Jitter will allow, it will introduce some randomness so that multiple retries do not cascade together. And then retry on process, payment process exception. So if this exception happens, then it will retry. So I showed in my previous video that these retries are happening with the help of logs if there are failures. And we should also ensure that retries are done only for recoverable errors. So for example, here this error, let's say, is a recoverable error. So then we may have a retry on this, but we may want to abort also on some exceptions, which is say critical payment exception or something which is outside our control, right? So here we may define I have to close this class payment resource. So double closure is there, so one is not required. And once we have this, we may have a exception also, so that just I have added to not have this compilation error in this particular. So here we have to surround sleep method with also try clutch block, so that interrupted exception. Or even better way would be to use throws. So this way I would there's not much we are doing on the interrupted exceptions. Similarly, we can have the critical payment exception based on certain condition. But I think this will be good for you to understand this. So you see, this is such a fault tolerant payment service which we have built, where we have used everything: retries, fallback, timeout, and I have explained them in detail also. It's not very complicated. It is fairly easy to understand. Now let's move on to something little bit more complicated, which is also not that common, so you may not be familiar with. We will be talking about the circuit breaker. Let's create a circuit breaker for this. So now let's move to the other service, which is the product service or inventory service. So I'm in the inventory service. In this, I'll go to my Java file where I have defined there is inventory service. Okay, not inventory, basically into the catalog service. Again, this is a well-defined service. So here let's create some circuit breakers. Let's talk about the get products. So if you are wondering what is this, this is again based on matrices, a timer matrix which will measure the time for this call and the number of calls which has been made. But yes, this if you look into the previous videos, you will understand these concepts in detail. Now let's talk about having a circuit breaker. So we have this method where we get the products, and for a product we may want to have details also. So this is a call where we get the product and then we get the product details here. So in this, to add a circuit breaker, we'll again use an annotation which is something like this. So let me come back to the method, get product. Yeah. So this has some matrices. I'll add a circuit breaker here. Yes. So this adds a circuit breaker. Now, what does it mean? Request volume threshold. So if there are more number of calls, this will prevent application to get overloaded. So here we are saying that, okay, only take 10 calls. More than that, please do not take. Right? So if there are more than 50%, so it will evaluate 10 requests. If more than 50% are failing, the circuit breaker will open and it will not allow more calls to come in. Right? So this is a very good mechanism through which we can ensure the system is running smoothly. And if there could be a delay also. So delay, what it does is it tells that please wait for 5 seconds so that the system is allowed to recover. Correct? So basically you measure 10 calls and see if there are more than 50% failures. If there are more than 50% failures, then you just delay all the calls by 5 seconds and then again half open the circuit. So allow some calls, and if 2 calls are successful, you make circuit fully open. And fail on will be fail on some runtime exception. So you can also choose which exceptions you should consider failures. For example, if the parameter which are coming from the request is invalid, then there is no need to have some circuit breaker because this is an error which is client error. So some exceptions which you can put, which can specify that this is breaking from backend. So hope now the circuit breaker pattern is fully understood by you. Right? Let me explain it again. So circuit breaker is fault tolerant mechanism which can protect your system for having repeated failures. So you can configure circuit breaker. You can have a call failing, and if you see that there are some number of failures, you can close the intake of further calls This you say that circuit breaker is open. So you have a threshold. If your failures for some volume of request bypasses the threshold, then what you can do is you can have a delay, and then it can half open the circuit, and again evaluate some calls, and if there are success, then you can close the circuit breaker. This means that the service will run normally. So this is another very good mechanism for ensuring fault tolerance. Now I'll be covering the last mechanism. There are two more mechanisms. One is the bulkhead. Bulkhead is more from theoretical nature, I can explain. So let's consider the concept of bulkhead. Then I'll also briefly cover the concept of asynchronous calls, which is very simple. If you have gone through multi-threading, you understand what is asynchronous. So bulkhead is a pattern for isolating or dividing your system into separate partitions. So I can add a bulkhead also to this service. I have put value equal to 5. This means only 5 concurrent invocations can happen at a time. Additional request will be rejected. So this is done to ensure that if you are running various services on shared servers, then one service is not impacting other service by eating up all the resources. This is also known as noisy neighbor problem. So there are two kinds of bulkheads. One is the semaphore based bulkheads. In semaphore based bulkheads, you have just the value, and semaphore will be used to control the number of concurrent requests, and it limits after the value is reached. And there is something called thread pool style bulkhead also. In this you have a queue. So here you can have waiting task queue, so you don't lose out all remaining requests immediately. There will be waiting queue, and after this waiting queue you will reject the request. So here up to 5 threads can be processed concurrently. Rest of them will be put in the waiting queue, and if more than 10 concurrent are there in waiting queue, then it will be rejected. But this is a better mechanism because you don't lose out that many requests. So this is about the bulkhead. And then finally we will cover about the asynchronous requests. So asynchronous requests is running your operations in a separate thread. So this you would already be aware of. I'm not covering it in that detail. But yes, let me quickly share if some content is there or resources there which I can share, so that you can look into it offline. Just hold on for a minute. I'm sharing you the details about asynchronous requests. So if we want any service to be running asynchronously, we can use that annotation asynchronous. So for example, if I have some analytics operation here, let's say get product count. This is an analytics operation, or we don't need this in regular user flow. So to improve the responsiveness of the system, we can use asynchronous annotation. So this will then always be invoked in a separate thread. Definitely, you can always have retries for asynchronous execution as well. So these are various mechanisms for fault tolerance in microservices provided by MicroProfile framework. So thank you for being patient. Having this session was really enjoyable for me. I look forward to see you in remaining sessions. For today, that's all. Have a nice day and happy coding.